I've always held a firm belief in the power of empiricism. A lifetime of study in the biological sciences has taught me that every phenomenon, no matter how strange or unsettling, can be dissected, understood, and explained through careful observation and analysis. The tales I heard from the locals about the haunted swamp in the heart of the Louisiana Bayou didn't faze me. Ghosts, spirits, and cursed lands, all remnants of a bygone era when ignorance and fear dictated human understanding of the world. But those days were over, and I was determined to prove it. As I made my way into the bayou, I marveled at the complex ecosystem around me. The cypress trees, Taxodium disticum, rose majestically from the water, their pneumatophores, specialized aerial roots, jutting out in a manner that suggested an intricate adaptation to the anoxic conditions of the swamp. The water itself, a murky blend of dihydrogen monoxide H2O and various dissolved organic compounds, teemed with life. The tannins from decomposing vegetation had leached into the water, giving it a characteristic brownish hue. The air was thick with humidity, and I noted the presence of various volatile organic compounds, VOCs, in the swamp gas. Methane, CH4, hydrogen sulfide, H2S, and traces of ethylene, C2H4, released by the anaerobic decomposition of organic matter. The elemental composition of the gases was fascinating. Methane, with its simple tetrahedral structure, consisted of one carbon atom, C, bonded to 4 hydrogen atoms, H, making it a potent greenhouse gas. Hydrogen sulfide, with its characteristic rotten egg smell, was composed of one sulfur atom, S, bonded to 2 hydrogen atoms, an indication of sulfur-reducing bacteria at work in the depths of the swamp. I set up camp on a small island of solid ground, feeling a sense of excitement at the prospect of unraveling the mysteries of this unique environment. The sun was beginning to set, and as the light filtered through the dense canopy above, it cast long, golden rays across the water, refracting through suspended particles of detritus and algae. I took a moment to appreciate the biogeochemical cycles at play here, the carbon cycle, the nitrogen cycle, all contributing to the delicate balance of life in this swamp. As I prepared my equipment, I found myself reflecting on the history of science. It was only a few centuries ago that people like me, rational, inquisitive minds, began to peel back the layers of superstition that had clouded humanity's understanding of the natural world. The scientific method had become the torch that led us out of the darkness, from the days when a lack of understanding led to the burning of those deemed witches, to the present, where we can sequence the genome of a microbe or send probes to the farthest reaches of the solar system. This swamp, with its dense biomass and complex food webs, was just another puzzle waiting to be solved. As night fell, the swamp around me became eerily silent. The usual chorus of Hyla cinerea, the American green tree frog, and Lithobates catsbianus, the bullfrog, was absent. The only sound was the occasional ripple of water, likely caused by the movement of an alligator mississippiensis, one of the swamp's apex predators. The absence of sound struck me as unusual. The swamp should be alive with the calls of amphibians, the rustling of small mammals in the underbrush, the hum of nocturnal insects. Yet there was nothing. It was as if the entire ecosystem was holding its breath. My mind turned again to the gases I had measured earlier, wondering if perhaps there was something unusual in the swamp's chemical composition that might explain this unnatural stillness. Methane and hydrogen sulfide were common in wetlands, products of the anaerobic respiration of bacteria, yet their concentrations seemed unusually high. Could this be affecting the behavior of the swamp's fauna? My thoughts were interrupted by a disturbance in the water, just at the edge of my vision. At first I dismissed it as a fish breaking the surface, or perhaps a branch falling into the water. But then I saw it again, a ripple, followed by a shape emerging from the water. I blinked, trying to make sense of what I was seeing. The object was dark, covered in what appeared to be a thick layer of algae and other epiphytic organisms, typical of submerged structures. But as it rose higher, I realized with growing unease that this was no mere log. The creature that emerged from the swamp defied all my expectations as a biologist. It was massive, standing at least 2 meters tall, its body covered in a thick layer of filamentous algae, possibly from the chlorophyta division, and slime. Its skin, if it could be called that, was a mottled mix of browns and greens, an excellent example of cryptic coloration, evolved to blend seamlessly with its surroundings. But what caught my attention most were its eyes, two glowing orbs of sickly green, emitting light like some bioluminescent organism. I stood transfixed, my mind racing through possible explanations. Bioluminescence was common in marine environments. Organisms like the dinoflagellate Noctiluca scintillans or the anglerfish Serradius holboli, but it was rare in freshwater environments and unheard of in a creature of this size. The creature's eyes seemed to be a form of chemiluminescence, possibly utilizing a luciferin-luciferase reaction similar to that found in fireflies, Lampyridae family, but how it had evolved in this swamp was beyond my comprehension. It moved towards me with an unsettling grace, its massive body slicing through the water with hardly a sound. I could hear the slick, wet sound of its movements, the displacement of water as it approached. My pulse quickened, a purely physiological response, the release of adrenaline, C9H3NO3, into my bloodstream, preparing my body for fight or flight. But I stood my ground, determined to observe, to understand. This was no ghost, no demon. It was a creature of flesh and blood, governed by the same biological principles as any other organism. As it neared, I saw its mouth, a wide gaping maw filled with sharp conical teeth, not unlike those of an elasmobranch such as a shark. Its breath was hot and foul, a mix of sulfur and decay, indicative of the presence of hydrogen sulfide, H2S, and possibly the breakdown of organic matter in its digestive system. The creature was close now, close enough that I could see the details of its grotesque form, the layers of detritus clinging to its body, the parasitic copepods, crustacea, copepoda, that infested its skin, the way its limbs moved with an eerie, almost mechanical precision. I felt a momentary pang of fear, a primal response deep within my amygdala, but I pushed it aside. Fear was for those who did not understand. I had to analyze, to dissect this situation, as I would any other. The creature's eyes locked onto mine, and I could see the intelligence in them, a calculating awareness that sent a chill down my spine. No, not a chill, but a somatic response, a sympathetic nervous system activation. Suddenly, the creature lunged, its long, sinewy arms, likely evolved for swimming, with a bone structure similar to that of cetaceans or pinnipeds, wrapping around me with a strength that defied explanation. The cold, clammy texture of its skin made contact with mine, and I felt a surge of revulsion as it began to drag me towards the water. My mind raced, searching for a solution, some way to escape. It was then that a thought occurred to me. The creature, like all aerobic organisms, required oxygen to survive. The water around us was saturated with methane, CH4, and hydrogen sulfide, H2S, gases that could displace oxygen, O2, and create a hypoxic environment. If I could somehow deprive the creature of oxygen, force it to take in the methane-rich water, it might release me. I knew that methane was less soluble in water than oxygen, and its uptake would lead to asphyxiation rather than respiration. With a desperate determination, I pressed myself against the creature, trying to maneuver my mouth near what I assumed were its respiratory openings, possibly gills, though hidden beneath the layers of algae and slime. I exhaled forcefully, expelling the carbon dioxide, CO2, from my lungs into its body, hoping to disrupt its oxygen intake. For a moment, nothing happened, and I feared I had miscalculated. But then I felt it, the creature's grip loosening, its body convulsing as it struggled to draw in air that was not there. When I forced my breath into the creature's gills, I realized I was introducing a significant amount of carbon dioxide, CO2, into its respiratory system. The influx of CO2, combined with the methane-rich water it was already exposed to, likely resulted in a form of acute hypoxia, similar to monoxide poisoning in humans. The creature's gills, designed to extract minimal oxygen from the swamp's anoxic waters, would have been overwhelmed by the sudden deprivation of O2, leading to a rapid buildup of carbonic acid in its bloodstream. This would have caused it to black out, unable to sustain its vital functions, and ultimately drown as its body succumbed to the lack of oxygen in its system. I pulled free, kicking away from the creature and swimming for the surface with all the strength I could muster. I broke through, gasping for air, my alveoli filling with life-sustaining oxygen once more. Behind me, I heard the creature thrashing in the water, its movements growing weaker, slower. I turned to see it sinking back into the depths, its bioluminescent eyes dimming as it was engulfed by the methane-rich waters. I crawled onto the shore, my body trembling with exhaustion and the after effects of adrenaline, also known as epinephrine, is C9H13NO3. This denotes that the molecule is composed of 9 carbon atoms C, 13 hydrogen atoms H, 1 nitrogen atom N, and 3 oxygen atoms O. As I lay there, breathing deeply, my mind began to process what had just occurred. I had survived an encounter with a creature that defied all known biological classifications, a living anomaly that would undoubtedly reshape our understanding of the natural world. But as I gathered my equipment, preparing to leave the swamp and document my findings, I couldn't shake the feeling that this discovery was not yet over. The swamp was a vast, complex system, with countless layers of life and death intertwined in ways we have yet to fully comprehend. I had survived this night, but what else lay hidden in those dark waters, waiting for the unwary? This encounter, this creature, would be the foundation of my doctoral thesis. I would study it, dissect its biology, and present my findings to the scientific community. The world would know what I had seen, what I had faced. But as I left the swamp behind, the silence of the bayou pressing in around me, I couldn't help but wonder if I had truly escaped, or if I had merely scratched the surface of something far deeper, far more ancient than I could ever imagine. I knew I only had maybe half a day to find and hire some of the local swamp people, alligator hunters, to come back and retrieve the creature. In my upcoming PhD paper, I intend to delve into the unprecedented discovery of what I've tentatively named Cryptomorpha tenebris. This creature, unlike anything previously documented, presents a unique set of morphological and physiological adaptations that defy existing biological classifications. My research will cover its bioluminescent eyes, an apparent evolutionary trait for navigating the swamp's murky waters, and its cryptic coloration, which allows it to blend seamlessly with its surroundings. The paper will also explore its symbiotic relationship with the epiphytic algae and parasitic copepods that inhabit its skin, and its adaptation to a hypoxic, methane-rich environment, suggesting a novel respiratory system possibly involving methane metabolism. Also its Achilles heel, as I was able to dispatch the creature by exhaling a blast of my own CO2 into its lungs. Based on these findings, I propose a new classification, Kingdom Species Tenebris. This new classification reflects the creature's amphibious nature and its divergence from any known species, making it a landmark discovery in the field of biology. Also, a simple warning in my paper for amateurs wanting to venture to this swampland: don't go there. It's fucking dangerous.